Okay, hi. I'm going to create a short video exploring the logic NAND gate. So the gate is called NAND, and this really stands for not and, which is a fundamental logic gate. If you know the AND gate, that's fine. There's videos up on the YouTube page that explore how the AND operation works. But we're going to look at two input NAND gate. Okay, and really we're going to have inputs A and B, and these go in to the actual gate itself, and we get out A, B with a bar that sits just above it. And this is the NAND gate. So let me just annotate this a tiny bit. So we have these two inputs here. So these are the input signals. These can be on or off. These here are the wire tracings. This is the actual gate itself, right? The actual component. And this is how we would represent the output of the gate. So we can see that where we have A and B together, this represents an AND. And then we have A and B with the bar above. This is the not AND. Okay, and we just see the actual construction of this particular gate. Well, it looks just like the AND gate. We have this kind of initial square with a circle at one end, but then it has this additional dot or circle just at the outside of the arc on that particular gate. Okay, so as normal, well, we should really consider how this gate functions, yeah? And so using a truth table, we can see how the gate works, yeah? So we say we can understand how the gate works. Okay, cool. So we have two inputs. We have A and B. So we want to construct the truth table with two inputs. Each of those inputs have two possibilities. And if we were to consider, well, what would an AND gate be? We would have A and B. So we'd have true and true would be true. True and false would be false. False and true is false. And false is false. Now the NAND gate gives us the opposite of what the AND gate gives us. So we get a false, a true, and a true. So then if we were to kind of describe this function, well, the NAND gate produces a true if one of the inputs are set to false, as we can see here. So as long as we have one of those inputs going into the gate, so in this instance here we have a true and a false, this will yield a true. Here we have the false and the true, which yields a true, and then we have the two falses, which will yield a true. In contrast, if we look at where we have the two trues going into the gate, well, this will yield a false. So the NAND gate will always produce a true if one of those inputs are set to a false. Okay, so that should hopefully make sense. So it's a simple logic gate, referred to as NAND, standing for not AND. And here we have a two input NAND gate. We can see the actual design of the gate itself and the signals that are coming in along the wire tracings into this particular gate, and then we get the output of the gate. And it's very important that if we can look and we can use truth tables, we can understand how the gate works. And this is for all logic gates, right, or for all functional expressions. The truth table shows us all possible combinations of inputs, and then the output or the resultant column shows us the function of that particular gate. Okay, so that should make sense. So the only thing we're left with is to draw a little happy face. Okay, thanks for listening.